The Music with Microcontrollers pack uses a single sys block and flow code to allow students to quickly construct a wide variety of digital music applications and understand the principles of digital music manipulation and effects. Students will gain an appreciation of D2A and A to D conversion and digital signal processing techniques that allows music to be sampled, delayed, and manipulated and produced in the digital domain. Students make use of signal generators, microphones, speakers and headphones to create and understand a variety of applications in music technology. The pack is suitable for students aged 16 plus with an interest in embedded programming and music. This is the program for an echo. Now there's a couple of things going on here. On the 2D panel, you can see this is our data flow program. And then behind it, you can see there is a more conventional flow code programming using flowcharts. The main flowchart routine is very simple. It just has a timer interrupt. And the timer interrupt, if you look at the properties of it, it basically says that on timer 1, what we're going to do is select an interrupt frequency of 44 kilohertz. 44 kilohertz is a bit of a magic number in audio because it divides nicely to produce the individual frequencies that we associate with the keys on a piano. So basically, all this does, this main program, is it says, sets up an interrupt. And every 44 kilohertz, it basically runs something called user macro. Now, user macro just has a load of icons here, each one of which relates to a data flow icon, and it just says activate this icon. What we then do is we set up the data flow program itself, and you simply drag and drop from the DSP component library, and you can see that here. So these are all the commands or icons that you can drag onto the panel. So you drag one of those onto the panel, you click on it and you set up the properties. So this first icon says activate the analog to digital converter, and let's take the sample from channel AN1, which is one of the A to D inputs on the microcontroller. What we then do is we delay that signal, and the delay count here is 20,000. Our sample rate is 44 kilohertz, so it's about half second delay. Then we have a little adder or a mixer, and the adder is connected both to the digital input and to the delay, and it basically adds those two signals, and it feeds the result to one of the output channels. In this case, it's port H, which happens to be one of the lines on the 3.5mm jack. So this is a great program. It's relatively simple, and it allows you to construct a very simple delay. And you can see from this and from all the other icons that you can use in the DSP library, you could see how you could construct lots of different types of musical effects, echoes, delays, reverbs, and so on. Now, just to let you hear how that program works, what I've got in front of me is a radio, and I've connected a small speaker to the sys block, and I've just got a standard BBC radio channel.
The king tries to escape. He shows that he's completely abandoned the revolution.
So that's the input audio. And if I just plug the speaker into the output and turn that speaker on, you can now hear that there is an echo on that signal. Okay, so to do that, you just compile that to your sys block. It takes 30 seconds to compile, and you've created a simple echo program. Now you can use the encoders and the switches and display to control that. So you could use one of the encoders to control the amount of echo or the amount of time of the echo, or you could create another program where you could alter the different amplitudes of the signals being fed into the mixer or to the output or whatever you like. And there's lots of sample programs that allow you to understand how the encoders and the switches on the sys block work. And we've made it very easy. There is a second microcontroller on there, but there's a special component in the flow code that allows you to just manage that all very easily. So that's an example of how the music with microcontrollers course is carried out. And what we do is we get students to construct lots of different types of program. We give them a lot of help to start with, and then we let them take more and more responsibility for constructing the program.